The last of the three sets that we're going to talk about is something called a tree set, and I'm just starting off in the IDE this time because I think it will be better to see how this works through an example. So, tree sets are, or they order their elements based on the natural order of the elements or through something called a comparator. Now, comparators we'll talk about a little bit later, but for now, let's talk about what it means to be ordered by the natural ordering of the elements. Think about a set of integers. So, what is the natural ordering of a set of integers? Well, the natural order is from least to greatest, right? So that's how a tree set is going to order integers in a set. Let's think about strings. How are strings ordered? Strings are ordered using lexicographical ordering. Okay? So anything that has a defined ordering will be sorted according to that with a tree set. Now, if we want, we could say that we don't want it to be sorted by that. We want it to be sorted by some other metric, and that's where the notion of comparators comes into play. Sorry, my cat is scratching on my chair. Okay, but again, we'll talk about comparators in a later example because there's a better data structure, or there's a data structure that is better suited for. Okay, my cat is going to jump in front of the camera in a second, or maybe he'll get in my lap. I don't know. Yeah, there he goes. So there's a better data structure to exemplify comparators. So for now, we'll just use the fact that tree sets order based on the natural ordering of the elements. So what does that mean? That means that when we traverse over the set, the elements will be ordered according to the natural ordering of that type. So for example, let's add the same elements that we added in this example. So let's just copy everything. So we know that because we're ordering based off the natural ordering of the integers, this is going to be printed in ascending order. So we're going to do -2, 9, 24, 42, and then not 42 again because we removed duplicates, 81, 91, 120. And if we run this, we'll see that that is correct. Okay. So now let's do another set example. Let's say we create a let's say we have a set of strings. Okay. So so let's create a set of strings with some names. So let's say we have Jane, then we have, let's use the names of my TAs. So we'll say Susan, Owen, George, Jack, Gilmore, let's see, Elliot, Joey, and I think that's fine. So how is this going to be ordered? Well, we're going to be ordered, or the strings are going to be ordered by the lexicographical ordering of the elements. And of course, my cat pushes everything off the desk. Sorry about that. So how are the strings going to be ordered? Well, they're going to be ordered according to lexicographical ordering, which is just the ordering according to the ASCII table. So we know that this is going to be ordered. Let's see, we have Elliot, and then George, and then Gilmore, and then we have Jack, Jane, Joey, Owen, and then Susan. So let's print out these elements like that. So we can use the enhanced for loop again, except we're going to use strings as the type rather than integers, because if we put int here, that would not compile. And let's just print out the strings, and let's see if our ordering is correct, and it is. So what have we learned about tree sets? We like tree sets when we want to remove duplicates, and we want the ordering of the elements to be dependent on the natural ordering of the elements of the set, or the ordering of some other means. And by some other means, I mean we can specify a different ordering for the element, and we'll talk about that in a separate video.